Today, we are going to be proving the derivatives of sine and cosine, right? Because it's good to know why these things are the way they are. You know, it's good to always ask why. But to do that, we're going to have to accept two limits as a fact, and we need these to accept these two limits since we'll be using the definition of a derivative. So on the right, we see the limit as theta approaches 0 of sine of theta divided by theta is equal to 1. And then the limit as theta approaches 0 of cosine theta minus 1, all divided by theta, is equal to 0. These two limits are a fact. They have proofs of their own. So if you ask yourself, why? You can go onto YouTube. There's plenty of videos out there to prove these two limits. But for our purposes today, we're going to just accept these as fact and get into our definition of a derivative. So let's start with sine of x, right? So the definition of a derivative, right? We already know this, right? So we're going to be doing the limit as h approaches 0 of the sine of x plus h minus the sine of x. And we are going to get to some long numerators all over h, right? Okay, so at this point you might be thinking to yourself, what the heck am I supposed to do now? Like I don't see a way to simplify this. But if you remember from a pre-calculus class, you may have received a page or two of an absurd amount of trig identities. And if you're like me, you probably thought to yourself, wow, I am never going to need to know these. Well, you're wrong, because we're going to use those right now, right? Because it turns out, by knowing those trig identities, we know, right, that sine of x plus h is the same as saying sine of x times the cosine of h. And here is where our super long numerators are going to come into play. Minus, or no, it's plus cosine x times the sine of h, and then we still have our minus sine of x all over h, right? Okay, good that we're there so far. Okay, so now how can we simplify this? You know, how can we manipulate this to work for us? Well, I see in the first and third term in the numerator both share a sine of x. So let's try and factor that out, right? Let's do that. So we have the limit, and this is a very tedious process having to rewrite everything, but we're doing it so we can learn. So let's factor out that sine of x, right? So when we take that out of the first term, we're just left with cosine of h. And then when we take it out of the last term, we're left with just minus 1. And then we've got plus cosine x times the sine of h all over h. And now I'm starting to see something. Maybe you see it too, but in case you don't, let's just pull the x terms in front of our h terms, just so that way this might become a little more obvious, right? So we have the limit, that's an m, the limit as h approaches 0 of, and this is what I mean by pulling out our x terms. We're just gonna put it in front of the fractions, that way it's a little easier to read, right? Cosine h minus 1 all over h. And then we have plus, we're pulling out that x term, just putting it in front so it's clearer, times the sine of h all over h. Now, you can see why we accepted those limits up in the top as fact, right? Because we have them here in our answer. So let's evaluate the limit, right, as h approaches 0. And when we do that, we're left with sine of x times 0, right? Because we know that from our limit at the top, cosine theta minus 1 over theta, we have the same thing, but with cosine h minus 1 over h. So that's 0 plus cosine of x times, okay, we know from our limit up there that sine of h over h as h approaches 0 is equal to 1. And so all we're left with is the cosine of x. And there we go. We just proved that the derivative of sine is indeed cosine, right? So now let's erase all this, right? And we're gonna start doing our cosine proof, and we're gonna do like literally the exact same process to prove cosine. So let me just erase all this. All right, we're good, and let's start with our definition of a derivative again, right? So the limit as h approaches 0 of cosine x plus h minus cosine of x all over h. And now we're going to do the exact same thing. We're going to use our knowledge from pre-calc and use one of our trig identities, right? Because it turns out, again, that's an m, the limit as h approaches 0. It turns out that cosine of x plus h can be written as cosine x times the cosine of h minus the sine of x times the sine of h. And then we have our minus cosine x still here. And all of this, isn't that the straightest line you've ever seen? All of that is over h. And again, in our first and third term, we could see that they both have a cosine of x, right? So why don't we just factor that out like we did with the sine of x in the first proof we did, right? So let's do this. Limit as h approaches 0. We're factoring out our cosine x, right? So when we factor it out from the first term, we're just left with cosine h. And then when we factor it out from the last term, we're left with minus 1. And you might already see that we've got some similar stuff going on, right? And then we're left with sine of x times the sine of h. All of this over h. And again, we're going to pull our cosine out in front of our x's in front of our h's to make this a little clearer again, right? Because, you know, it's always nice to just see things clearly. So we got the cosine of x times cosine h minus 1 all over h minus the sine of x, times the sine of h over h. And now we are back to using our limits that we know is a fact, right? So we're gonna evaluate our limit as h approaches 0. So what we're left with is cosine of x, and then the limit as h approaches 0 of cosine h minus 1 over h is equal to 0. We know this from our limits up in the top right. And again, if you want to find a proof for these, there are tons of videos online. I encourage looking at those because those are pretty cool. And now we have minus sine of x. Limit as h approaches 0 of sine of h over h we know is equal to 1. And now all we're left with is negative sine of x. And like that, we have proved that the derivative of sine is cosine, and the derivative of cosine is negative sine.